Hello, my name is Trevor Duffy.
And I'm Marie-Claire de Saimana. We both go to Embry-Rideau Aeronautical University.
This is our midterm project for EGR 305, Section 1. We did the vertical steam engine. The goal of the project was to create parts in CATIA, which would come together in an overall assembly to produce the vertical steam engine. The engine gets its name due to the cylinders being in an almost upright position. The odd parts were done by Marie, the even parts were done by me. The standard hardware was looked up in the CATIA catalog and added as needed. On the left shows a list of the parts that were done.
These are odd parts that I modeled, 1 through 17, and this is a continuation of those. This is the part that I found most difficult, only because the dimensions which were provided were hard to localize. The figures such as those holes, because they had different shapes and sizes, it was difficult to localize them. So therefore it took much time compared to other parts that I designed. And these two parts, the rod which goes in the subassembly 11 and the pin which goes in the subassembly 7 were the parts that I found most easy, because there were only one sketch, which I sketched as a cycle, and then I padded. Even though these parts were part of a subassembly, I did not use subassembly, but in the end, I found that it would have been easier actually to use in a subassembly.
These were the even parts 2 through 16 and 24 modeled by me. This is the continuation of the even modeled parts by me. These are the even parts that I found difficult. It was the cylinder itself and then also the reverse switch. I found them to be difficult because it was challenging to get the holes and the pockets to line up where they needed to go on the part. The reason that I at least found this challenging was because I had to create my own axis and then base the holes off that axis and then pocket or hole them all the way through to get the finished product. Also, the drawings were slightly challenging to interpret because everything wasn't localized to one side, or it was hard to locate some of the dimensions themselves. These were the even parts that I found easy. They were the flywheel and the crankshaft. The reason I found them to be easy is because I actually only did half of the part itself, and then I used the revolve command, the whole 360 to create the part. And then after I did that, I created one hole and then used the pattern cylinder command to create the rest of the holes on the flywheel so that everything was evenly spaced and it was done in one go. On the crankshaft, I had to do the axis again, and I found that to be easier on this one because it was either straight up and down or off to the side on the holes that I had to make.
The standard hardware parts were easily found in the CATIA catalog because the names given in the part list were matching the CATIA catalog, and it was easy to put them in the assembly because they were fitting in the standard holes that we created.
This is the overall assembly, the final product, if you will, and the constraints that we mainly used were the offset constraint, the coincidence constraint, and the contact constraint, and that made the product work, or the assembly work. When we exploded the final assembly and updated it, it all came back together and everything went back into the correct spots. We didn't have any problems using those constraints, and it made that part easy.
In conclusion, the project was a success. The only difficulty that we're seeing were through the dimensions. Some of them were hard to locate,